All right, so what the book is trying to do is this, okay? So one of the things we need to know is this, that the square root of x is equal to x to the 1/2, okay? If you take calculus, we use this a lot. It's really important, right? And at the same time, we should be able to know that the cube root of x is equal to x to the 1/3 power, right? And if we have the 4th root of x, it's going to just be x to the 1/4 power, okay? And they just use that opportunity to prove why that's true. So they go ahead and prove the whole thing here. Now, they do say this, x is greater than or equal to 0, okay? Shh. Children, I'm recording. So the book says, well, make sure that you keep in mind that x must be greater than or equal to 0. Okay, well, why? Okay, why? You know the answer to this. Why is this important? Right, you can't have the square root of a negative number. Okay, so if you have the square root of a negative number, it's going to be unreal, and we are not doing imaginary numbers. Okay, we're not. So it's just, there's no solution. Okay, so one of the things we know is if we do have the square root of a negative number, it's going to be an I, right? So for instance, the square root of a negative 4 we know is 2i. That's great, but we're not going to have that answer. So for us, there's going to be no solution, okay? Now, one other thing I think we need to add, and that is, we talked about this earlier, is if we have this, and this I want you to write down. If we have x, if we have x to the p over r, that can be rewritten as this. X. As an example, if I have 8 to the 2/3, okay? The p, so it's a fractional exponent. The top part is the power, and the bottom part is the root. So when you get a fractional exponent, if your exponent's a fraction, if this is a fraction, the bottom number is the root. So this would be a cube root. It's going to be a cube root squared. Say it again. It's going to be a cube root squared. Now you could do this on your calculator. You really can, because it's just numbers. Okay? You could go, okay, all right, I'm going to take, let's see, 8 to the power of 2/3, and the answer is 4. Let's see why the answer is 4. Okay, the answer is 4. Here's why the answer is 4. We're going to rewrite this as the cube root of 8 squared. Yes. So, 2 ways to do it. Reese, you did it the way I don't like to do it, and I'll tell you why. Because you did this first, and sometimes it gets you really big numbers, right? Mm-hmm. You can. I like to do the root first. They're both correct. We're both correct. I like to do the root first because it makes it small first. Does that make sense? So what I do is I like to go to the cube root 8 is 2, and 2 squared is 4. Now Reese did it the other way, and it works. Reese is correct, absolutely correct. Reese said,
I used PEMDAS.
Well, and I could put the 2 on the outside, but it doesn't. Either way, you're correct. You could go 64. You could go the cube root of 64, which is also 4. Very good, Reese, by the way. Very good, okay? All right, how am I doing? So far, so good? All right. So let's take a look at page 545, okay? Actually, no, I'll just turn the page. I want to take a look at this next page, okay? So, all right. So we know the cube root of x, cube root of x is the same as x to the 1/3 power, okay? Everybody agree with that? Very important you know this. If you ever take calculus, you have to know this. And then the cube root of x squared is just x to the 2/3 power, right? All right, so let's take a look at what we have here, okay? Am I doing okay? Am I going too fast?
Yeah, one second.
Okay. So there's an invisible 1 right here that we just don't write, and that's where the 1 comes from. There's your 1/3. There's an invisible 1 there.
Okay, I got you.
Okay, so now if we go and look at this one, we can go straight to x to the 2/4. Do you see it? Or it's the same thing as x to the 1/2, right? So you see the 2/4, right? 2/4, everybody okay with that? And then restriction is x has to be greater than or equal to 0. Because it's the square root, right? Okay. Another example, we'll take the 4th root of x cubed. Aida. Thank you.
It's not just 255.
Okay. And then I can, what do you rewrite that as? It's going to be the same thing as x to the 3/4. You guys agree with that? Right? And then we're going to say, all right, well, but do you need a restriction on this one?
No.
Yeah, you still do, because you could wind up with a negative value in here, couldn't you? Yeah, so x still has to be greater than or equal to 0, right? This would have been the 5th root of x squared, which is the same thing as 5th root of x squared, same thing. Now, if you're doing a 5th root, no restriction. Why is there no restriction on this one? I want you to think about this one right here. Will it ever, first of all, can you take the 5th root of a negative number?
It's an odd number.
It's an odd number. You can. You can take roots, odd roots of negative numbers. Plus, this will always make it positive anyway, won't it? Okay? And then finally, if we took the, what do I have? Well, they just want us to do this a root of x to the b, and they want us to go straight to x to the a, b over a. And the restriction is only if a is even. Do we need a restriction? So only if the root is even do we need a restriction, okay? Now they do something really weird on the next page, and I'm not going to do this, okay? I'm not going to use the absolute values, but they do, and I'll tell you why they do the absolute values, okay? So I'll wait for you, okay? So we know that if the root, if this is odd, there's no restriction. But if this is even, you have to keep it positive, okay? All right, now, if I take a look at this page, am I going too fast?
No.
I need to.
Okay. So when you look at the next page, they've got all these weird absolute value thingies. So I'm not going to worry about this, okay? So we're not going to worry about this, but let me show you what's going on. Okay, we've done this. Cube root of 8, we know cube root of 8 is going to be 2. We take a third of the exponent. Okay, you guys agree from here to here? Do you agree with that answer? See that? Do you guys agree with that answer? Okay, cube root of 8 is 2. Take 1/3 of the power, right? Be okay with that? And then they do it with exponents, so you can see why it's a third of it, and you get the same answer. Okay. Now I want to jump down mostly to right here, Embry and Devon. Okay. What you see is this absolute value. So let's do this real quickly. I'm going to do it down below. 4th root J8 K4, right? So, right here, k can never be negative. K will never be negative because it's to the fourth power. So they do just j squared k. That's the answer. What did I do? I took a fourth of the exponent. So let me show you the other way. Okay? Same thing as j8 k4 to the 1/4 power, right? And then my answer has to be j squared k, k to the 1. They use these absolute values. Don't worry about it. You do not need the absolute values. They're saying make sure k stays positive. That's all, okay? Thumbs up. Does that make sense? I got from here to here? Am I going too fast?
No.
Okay, am I okay? Does this make sense? I got from here to here? Okay, turn the page. All right. Now, same thing here on Betty. We have the square root x squared y squared. And we get straight down to x times y, right? We've done this before, right? They use the absolute values. We do not need the absolute values, okay? All right? Let's jump down to 4. How about m squared over n cubed? Okay, you all right with that? I took half the exponent, remember? Half, because it's the same thing as m4 n6 to the 1/2 power, right? This one's going to be a k4 over, I'm sorry, j, my bad, j4 over k, because I took a third of the exponent. I took a third. I know that I could rewrite this. Another way to do it would be j12 k3 to the 1/3 power. Okay, that's another way to do it. But I think if you just remember that it's a cube root, take a third of the exponents, right? We'll get it. Okay, now, if I slide down to the very bottom here, Bernadette and Chris, they do this two different ways, okay? Now, watch this, okay, watch. I do not like Bernadette's way, personally. You can look at Bernadette's way if you want to. That's not the way I like to teach it. This is the way I teach it, okay? Because we reduce the root. So what did Chris do? He did what we did. Chris took the cube root of 8, the cube root of 2. Chris took the cube root of x6 and the cube root of 2. Oh, x, I'm sorry, my bad, x. Sorry, so sloppy, okay? This is what Chris did. We know 8's a perfect cube root, right? And Charles, you see Chris kind of does it the way I do it, right?
Yeah.
But it doesn't matter. Everybody agree that that's 2, right? I made this a 6 because I can take a third of it, right? Right? Oh, so sloppy. Must be Friday. So I take a third of that exponent and I get x squared, right? And then these two can't be rooted, so they have to stay inside the cube root symbol. So if you want to take a look at what they did, both Bernadette and Chris did their problem slightly different than I do. Slightly different, but we got the same answer, okay? All right, that's all I have for today. We're going to Mathia, and I've got homework. So the homework's going to be here, page 147. Super easy.